So the entry point of the system is the FTP service. FTP service was chosen because FTP happens to be the most common protocol used by the sensors, the cameras, to provide data to other systems. But naturally, the system is not limited to it. We can write services which can extract data from live streams, from H.264 streams, from MPG streams, and other ways. We'll again talk about that in some other session, but let me start with the FTP service. The code mostly is self-describing. There isn't a lot of complexity to it. We start with the main routine. So we read some environment variables to help us with development scenarios or production deployment scenarios. We change URLs to servers and other things accordingly to make life easier for us, so nothing major there. We have a dummy authorizer for FTP. For now, the username and password are hard-coded to user and 12345 as password. So if you want to test the system after deploying it in any way, you may end up using these credentials to connect to the FTP service and upload files. The home directory is set to the current working folder. So I mean, when you're running this as in the development phase, you will get to see all of your files if you run the FTP service from here. But if you use one of the Docker container images to run the system, then you will not see a lot of things because the image is configured to keep the some things segregated from the code. So the first thing the service does is try to connect to the AMQP broker, which is RabbitMQ. Once the RabbitMQ is ready, we simply start a FTP server loop, and the server listens on port 2121. And whenever it receives any file, this callback function is invoked. Just on a side note, in each of the services we'll get to see one of these signal handlers. These handle the control C or kill signal events in case, so that we can gracefully shut down the services. So coming back to the handler, so the handler is basically a class which extends from the FTP handler. So I'm using a pre-built FTP library available for Python. Nothing done there from me, so I'm just following their conventions. So this class, when it receives the files, it just queues that into a queue declared somewhere, and afterwards we have a dispatcher routine which connects to MongoDB, and it's continuously monitoring the queued image queue, and whenever it finds there's an image queued, it sets certain parameters such as the unique ID, the file name, the creation time. So let's say if you want to extend the functionality of extracting extra information from the file names, you can do so over here while constructing the message object, because this message object is later saved to the database as well. So we create a unique file name based on the unique ID we generated for this image, and then we move the file, whatever it was called, to that unique name. The reason for doing so is to avoid file naming conflicts. We don't want to do the overhead of trying to manage if two files with the same name are uploaded. So even though if you'll be uploading files to FTP with the same name over and over again each time, an internal unique ID will be generated for each of the files, and it will be placed to a storage location. Once the file is stored into an internal location, the associated content is saved to the database, The collection name is LPR events. And finally, we publish the same message over to AMQP. This is the complete life cycle of the FTP service. That's all it does. So let's say if you want to integrate the user authentication to your Radius server, or you want to integrate the user authentication using something like Active Directory, you would need to integrate the code over here. So if you look up the documentation for Python's FTPD lib, you'll find some samples or some ideas how to do that. For the sake of the demos and the basic configuration present on the internet by default, it's fixed to a hard-coded username and password combination. You could also link this to some sort of internal database containing your usernames and passwords. So this is the complete life cycle of the FTP service. That's all it does. It just listens on a specific port, it queues files, and then it just pre-processes the files, moves them somewhere, assigning them a unique ID, and associated information is published to the RabbitMQ exchange and saved to the database.